Chapter 6, Chemical Reactions. An introduction. Chapter 7 talks more about them. So, see, 3 little sections. Okay, evidence for a chemical reaction. We've talked about what a chemical reaction is. A chemical reaction is the same as a chemical change. And you're going to need to know that on the lab practical exam today. The idea of the chemical change is that the particles composing that substance are changed. So it's not something like a state change or cutting something in half. When water freezes into ice, the individual water molecules remain the same. When gasoline burns, the gasoline molecules are destroyed and new substances are formed, and that is a chemical change. There are some clues, some evidence that a chemical change has occurred, and we did this in lab last Friday. No, we didn't have class on Friday. It was the week before. It was the last Friday we had class, whenever that was. Never mind. So chemical reactions often give some sort of a visual signal, not always. Okay. So what are these concepts of chemical change? If the color changes, and this is a permanent color change. When you heated the copper wire in the flame, before you heated it, it looked like a new copper penny. It was copper colored. After you heated it in the flame, it was black and it wasn't shiny anymore. That's a permanent color change, and that's because a chemical reaction occurred. The copper reacted with oxygen in the air and formed a new compound. Another evidence or clue is that a solid forms. And what we mean here is if we take 2 liquids and we mix them together and a solid forms, that's evidence that a chemical change has occurred. We've created a compound that is not soluble in water, and so it forms a solid. Sometimes it's not obvious that a solid is being formed, but if the solution turns milky or cloudy, why is it cloudy? Why can't you see through it anymore? Because there are little tiny solid particles that have formed. If you wait long enough or use a centrifuge, you can actually get those particles to separate out, and you can see them in the bottom of the test tube. Another clue is bubbles forming. And the more general idea here is that a gas is being given off. So if you mix baking soda and vinegar, that's what in elementary school you may have made a volcano, and it bubbles and fizzes. Well, carbon dioxide gas is being given off. That's a new substance that wasn't there before, and so that's a chemical change. Another thing is heat being absorbed or produced, or a flame being produced. When we light a Bunsen burner, there's light given off and heat that's given off. That's evidence that there's a chemical change. That energy in the form of light and heat is coming from somewhere. It's coming from the stored potential energy within the chemical bonds, and in that process of that chemical change, the energy is being released. The substance is being destroyed. So if you mix 2 things, like you get a glow stick from the dollar store, right? And you crack it and it starts to glow. Is that a chemical reaction? Yes, it is. Inside the glow stick is a little tiny glass tube with one substance in it, and then around it is another substance, and when it makes that crackling sound. That's glass breaking inside. And that allows the 2 solutions to mix. As they mix, they give off light, and the chemical reaction is occurring. Same thing happens with the instant cold packs or the instant hot packs. You break open the little capsule inside and mush it around, and it's like magic, isn't it? It gets cold all by itself, or it gets warm all by itself. Why? There's a chemical reaction going on. So, not all chemical reactions give these clues, but if we see one of these, it's very, very likely that we have a chemical reaction occurring. So, what is the clue in this illustration that a chemical reaction has occurred? Here we've got a 9-volt battery and a glass of water. What do we see happening? Bubbles are forming. So the evidence that a chemical reaction is occurring is bubbles are present. Come on, iPad. Okay, so bubbles are present. I don't know where that color came from. Bubbles are present. And that's something you can try at home if you want to. This is electrolysis of water. The current from the battery is going through the water and destroying the water and creating oxygen gas and hydrogen gas. Let's look at this one. Fine. Stupid thing. In this example, we have two solutions being mixed. So it says a colorless hydrochloric acid solution is added to a red solution of cobalt-2 nitrate, turning the solution blue. What's our clue here that it's a chemical reaction? Color change. So the color changes. Another one. A solid forms when a solution of sodium dichromate is added to a solution of lead nitrate. What's the evidence? Solid forms. So if you look carefully here, this solution is yellow, but it's clear. You can see through it. It's like, I don't know, apple juice or something. And this looks like water. It isn't. But when these two things are mixed together, it becomes cloudy and we can't see through it. And that tells us that a solid is being formed there.